So these lakes and streams have different regions of depth that we can talk about and different things that happen in them. So it is the littoral, benthic, limnetic, and profundal zone. So they're shown here nicely on the diagram. So the littoral zone uh, is kind of the top around the edges. It's where plants can grow from the soil and reach the surface. There's lots of invertebrates that live there. So then there's lots of fish, turtles, birds, and amphibians that live there because they feed on them. So there's more biodiversity around the littoral zone because also the sun can still penetrate. So there's lots of greenery and lots happening around the edges of the body of water. Then we have the benthic zone, which is the area of from the shore to the deepest point. So it's basically the bottom. And it is where it's home to invertebrates that live in the mud and feed on detritus, but the sun does not penetrate down there. So there is energy for the living things to eat down there because they live in the soil. Excuse me. They live in the soil, so they can eat all the dead things that fall to the bottom, but there's no plant life, there's nothing like that because the sunlight doesn't penetrate down there. Then we have the limnetic zone, which is the open portion that's really far from shore. So this is the shore, that's the open portion that's far away from shore. The sunlight does go through the limnetic zone, so there is photosynthesis can happen. So we have phytoplankton, which are using photosynthesis to make food, and then the zooplankton eat on those, and then invertebrates and fish can feed on the zooplankton. So there is more life happening, where's my mouse? Here, because the sunlight allows for phytoplankton to live and make energy. So there's only going to be things living there if they have a source of energy. The source of energy around the edge here is the photosynthesis, is the soil. There's a lot happening there. In the benthic zone, the source of energy is the dead things that fall down to the bottom of the ocean, as well as, so they have energy through there, the decomposers, so things can feed on those. In the limnetic zone, the source of energy is the phytoplankton, which allows for there to be a food chain. Then we get to the profundal zone, which is between the limnetic and the benthic zone, so it's not on the bottom, but sunlight doesn't penetrate it. So there's no photosynthesis, there's less dissolved oxygen. So dissolved oxygen, it comes from photosynthesis happening in water because oxygen is a byproduct of photosynthesis. So there's not much life happening in the profundal zone. Ponds and lakes can change over time as rivers and streams bring them nutrients. So there's a couple of different kinds of lakes here. We have what's called oligotrophic lakes and ponds that are low in nutrients but high in oxygen. And then over time, the addition of nutrients can transition the lake or pond to be eutrophic, which means high in nutrients, low in oxygen conditions. We've seen that before with eutrophic zones and dead zones from cultural eutrophication from runoff, too much fertilizer with nitrogen or phosphorus in it. And then given enough plant growth, the water body may completely fill in. So it would become completely filled in with plants. So and not be as much of a body of water anymore. So plants or ponds and lakes are constantly transitioning as rivers and streams and precipitation and things like that change what's feeding into them. So freshwater wetlands include marshes, swamps, bogs, and vernal pools. So wetlands are systems where the soil is saturated with water, often containing standing shallow water. So basically where the water table is all the way up at the surface so that the soil is very, very wet and there's standing water as well. So freshwater marshes consist of cattails and bulrushes that grow above the water's surface. Swamps also contain standing water, but are usually in forested areas. And bogs are ponds covered in thick floating mats of vegetation. So just a little bit of differentiation between the different kinds of wetlands, but basically there's lots and lots of vegetation. If you have ever driven to Playa del Rey, off to the right there, if you're on Culver Boulevard, is the Bologna wetlands. So that would be an example of a wetland, especially during this rainy season. There's a lot of water there. And in the drier seasons, it's still very wet, but there's not as much standing water. So that's a real life example of a wetland. They can be seasonal. So there's specific kinds of seasonal ones that are called vernal pools that form as the snow melts in the early spring and then dry up later in the summer. And they have a lot of animals that have co-evolved to take advantage of these bodies of water. So they'll be there when there's water there, and their life systems revolve around the fact that there's water there sometimes and not water there other times. And wetlands provide many water-related ecosystems, including slowing runoff. So as water will run off, they'll reach a wetland and the water will stay there instead of continuing to run off, which can also help reducing flooding because it can hold onto water instead of letting it flood. It recharges aquifers because as the water sits there, it can seep down into the aquifer in a recharge zone, and also filtering pollutants. So they are very important, the wetlands. Wetlands have been heavily impacted by human activities, including draining and filling for agriculture, withdrawing water for irrigation, and construction of dams. So now a lot of them are being protected. I think the Bologna wetlands are protected. And so Canada and the US, so northern North America, have lost more than half their wetlands since the Europeans arrived because of human activity. Okay. Human activities also can affect waterways. So water is one of our most precious resources, and it is renewable. We have fresh water, and we get more fresh water when it rains. We get more fresh water when the snow melts. But the problem is that it is an exhaustible renewable resource, which means that we can use it faster than it can be recharged. And so that's what happens when we withdraw water at unsustainable levels. And we're constantly depleting many sources of surface water and groundwater. We need the water to live, not only to live to drink water, but we need it for our houses, to take showers, to use the toilets. We need it for farms and factories too. So we are using a very large amount of fresh water. The construction of engineered waterways like dams and canals have altered an estimated 60% of the world's largest rivers. So we have modified a lot of the rivers to suit our human activities and economic goals. And so we've changed about 60% of the world's largest rivers. So freshwater and human populations are unevenly distributed around the earth. There are some regions that will never have a shortage of water and some that are in a constant shortage of water, which you could probably assume just by knowing about the biomes, right? There are some biomes where there's lots of precipitation and there's some where there's almost none. So that would be the climate difference, and also the other factors have created varying amounts of groundwater, surface water, and precipitation across the earth. So you can see that the available freshwater in cubic meters per capita, so you can see that largely in Africa and Europe and Southern Asia, it's in those lower 2,000 to 5,000 and below. And then we have the US, which is kind of smack dab in the middle, and as well as other parts of South America, parts of Africa and Indonesia. But then we have like the northern areas like Canada and Russia, Northern Europe, and Australia that have lots available, and other specific regions in there. So it drastically varies by region how much is available. The distribution of human population does not match this distribution of water. So that means that because these regions up here are not where the majority of humans are living, you know that. Most of us don't live in northern Canada or northern Russia. We don't live in Siberia. So we don't have an adequate water display. And it's also distributed unevenly in time as well as in space. So not only spatially is it distributed, but for example, in India over here, monsoons give half of the region's annual rain in just a few hours. So if you think about the total amount of rain that they get every year, that's India, not over there. That's India. They get half of the amount that they would get all year in a few hours. So that's not really helpful because then they'll have a few maybe weeks or months of water and then they won't have it for the rest of the year. And then rivers also have seasonal differences because of rains and snow melt. And so a lot of times we build dams in order to save the water because there is water there, but we just need to make it last longer. And climate change has continued to worsen these conditions. So water supplies households, industries, and especially agriculture. Agriculture accounts for most of the freshwater use, about 70%. Industry is about 10%, and then industry is about 20%. Residential use is about 10%. And the expansion of agriculture since the Green Revolution has really led to the need for water. So the increased demand for irrigation has led to consumptive use of aquifers and surface waters where we remove water but do not return it. So we're consuming it is what it means. So we're taking water out of the aquifers and out of the surface waters, we're consuming it and not returning it because we are using it to spray on our food, using it to cool our factories, whatever it might be, to spray on our crops, not specifically on our food. Then there's non-consumptive, which means we are using it but not consuming it. So in that case, that would be with a hydroelectric dam, we're using the water to power the dam, but then we are later returning the water to the system. So downstream, the water would be returned. So that would be non-consumptive use. As you may have guessed, excess water withdrawals can drain rivers and lakes. So the excessive withdrawal of surface water has led to many world rivers running dry before reaching the sea. And a really good example is the Colorado River, which is what's happening in our region of the U.S. It doesn't reach the Gulf of California, between Baja California and the rest of Mexico. It doesn't reach there anymore because we take all of the water out of it. Same thing with the Rio Grande along the U.S.-Mexico border and China's Yellow River. This drastically alters the ecology of the river and the delta, the land around the river. So water mining, which is a withdrawal of water faster than it can be replenished, is taking place in many regions. You can see heavily in the United States right here, especially with us. We're highly overusing the water. Then we have we see adequate supply around in a lot of places. So 15 to 35% of water withdrawal is unsustainable, meaning that we're taking it out faster than it can be returned. The aquifers are being deleted, and the California agricultural region farmers are mining the groundwater, and that's why it's being taken out so much. So the effects of surface water depletion are very evident with the Aral Sea on the border of Uzbekistan and Kazakhstan. So this is a picture of the Aral Sea in 1987. This is what it looked like. But what happened was they used it. They started cotton farming during the USSR. When the Soviet Union was there, and so they diverted all the rivers that led to the Aral Sea in order to flood the ground to grow cotton, and so now it has less than 80% of its original volume. It's basically entirely dried up because of the cotton farming, and so there is no more cotton farming, and the sea is gone. And so it was definitely a poor use of water. We've lost 60,000 fishing jobs, and now there's all the pesticide-laden dust from the dry lake bed is blowing off, spreading pesticides, and we don't really farm cotton there anymore. Additionally, not only surface water can be depleted, but groundwater can be depleted. Remember, groundwater is the water that's stored in the underground aquifers in the porous spaces in the soil. And it's depleted more easily than surface water because it recharges so slowly. It can take a long time for surface water to recharge. So as aquifers are mined, the water tables drop. So think about that sponge in the Tupperware with water. If you take the water out, the water inside the sponge will dry out as well. And California has seen falling water tables across the state, reaching up to 10 feet in some places. So literally, we think about it in how high it is. We've dropped it 10 feet in some places, especially because of the drought that we've had for the past few years, which we're coming back from, but the drought has been pretty crazy. When groundwater is over-extracted in coastal areas, so if we take away too much fresh water from the ground along the coast, what happens is then the seawater starts to seep in. And this doesn't normally happen because there's water in there and it kind of pushes back. So it's already kind of filled, so the seawater doesn't have space to come in. But if the groundwater is gone, then the seawater will flow in and take up that space. And so coastal regions in California, Florida, India, and the Middle East now have coastal wells drawing up saline water instead of fresh water. And that's not good because we use those for drinking and we can't drink salt water. And as aquifers lose water, they become less able to support the overlying strata, so the layers of earth above them. And the land surface will kind of start to fall. This can lead to buildings to lean or sinkholes, which is where the land suddenly collapses because there's not supported by the water anymore. And after the ground subsides, after it lowers, it can be harder to recharge because now those porous spaces are gone because they've been compacted down since there was nothing there to hold them up. Groundwater also supplies our bottled water. So bottled water has become a booming business with $160 billion in sales worldwide in 2015. And people buy bottled water for convenience and taste, although blind taste tests have shown no preference and that it's really not safer or healthier than drinking tap water in most places. And bottled water has major ecological impacts with energy costs 1,000 to 2,000 times greater than tap water and 1.5 million tons of plastic waste generated annually. So drinking bottled water is very, very bad.